Unit 4, Section 11.7 Worked Examples. How many 4-digit numbers can be formed using the digits 0, 1, 2, 3 through 9 if repetitions of digits are allowed? We can work this problem using the fundamental counting principle. We want a 4-digit number. We notice there are 10 digits that we can select from, and we're allowed to repeat. So for the first digit in our number, we have 10 choices. And for the second digit, we also have 10 because we're allowed to repeat, and 10, and 10. And if I take my calculator and I raise 10 to the 4th power, I will get 10,000. So for this problem, there are 10,000 4-digit numbers that can be formed. Now let's change the problem a little bit and say that we're not allowed to repeat. So now when I go to my first digit, I still have all 10 to select from, but once I've selected the first digit, I can't use that digit again. So then I have 9 for the second digit, and then I have 8, and then I have 7. And so taking my calculator, I'm going to go ahead and multiply. I'm going to take 10 times 9 times 8 times 7. And so now I've got 5,040. So if I notice, I've almost cut in half the number of possibilities by putting that restriction in that I'm not allowed to repeat. In how many ways can 8 people line up for play tickets? We can work this problem using the fundamental counting principle. At the beginning of the line, we have 8 people to select from. Once we've picked that first person, we have 7 for the next slot, 6 for the next slot, and so forth. And again, let's get my calculator up, and I'm going to take 8 times 7 times 6 times 5 times 4 times 3 times 2. So I've got 40,320 ways that those 8 people can stand in line for the tickets. 40,320. A person can order a new car with a choice of 6 colors, with or without air conditioning, with or without heated seats, with or without anti-lock brakes, with or without power windows, and with or without a DVD player. And how many different ways can a new car be ordered in terms of these options? We can work this problem using the fundamental counting principle. And if you notice, there are 6 options for the car. We have the color, the air conditioning, the heated seats, anti-lock brakes, power windows, and the DVD player. For the colors, there's 6 possibilities. For all the other options, there's only 2 options, with or without. And so I've written down the 6 possibilities here. I've got 6 for the colors and then 2 for the other 5 options in the car. And if we take our calculator and we're going to multiply 6 times 2 times 2 times 2 times 2 times 2. So there's 192 ways, different ways that we can order that car. A teacher and 8 students are to be seated along a bench in the bleachers at a basketball game. In how many ways can this be done if the teacher must be seated in the middle and a difficult student must sit to the teacher's immediate left? We can work this problem using the fundamental counting principle. So we have 9 spots to fill. We have the teacher and 8 students. The teacher has to be in the middle, and the difficult student has to be to the left of the teacher. And so there's 7 slots left. And so for the far left slot, we have 7 students to pick from. So we have 7 that we could put here. We have 6 we could put here, 5 here, 4 here, 3, 2, and then finally the last student we have to pick from. And if I pull up my calculator, I'm going to take 7 times 6 times 5 times 4 times 3 times 2 times 1, and I get 5,040.